Hello students, let us continue with exercise 9.2 of chapter 9, areas of parallelograms and triangles. This is question number 2, wherein it's been given that ABCD is a parallelogram and EFGH are the midpoints of sides AB, BC, CD and DA respectively. Now we need to prove that the quadrilateral formed by connecting the midpoint, that is EFGH, is half the area of your parallelogram ABCD. So how do we do that? Obviously this exercise, as I told you earlier, is going to be based on the fact, on the concept that we learned that parallelograms on the same base and between the same parallels are equal in area, and we also learned one of the proofs that the triangles and parallelograms on the same base and between common parallels, the area of triangle is going to be half the area of parallelogram, and this was the universal this is the universal concept also. So what we will do is we will connect H and F. So now when you connect H and F, see what happens. These are the midpoints, right? We have that AD is equal to BC. Why? Because they are the opposite sides of the parallelogram. So AH is equal to BF, correct? Because H lies between A and D and F lies between B and C. Also, half of AD is going to be equal to half of BC, because AD is equal to BC again. Why? Because they are the opposite sides of the parallelogram. But since H and F are the midpoints of AD and BC, what can I say? That AH is equal to BF. Now in this quadrilateral ABHF, I have a pair of opposite sides equal and parallel. Therefore what can I say? That quadrilateral ABFH is a parallelogram which makes AB and HF parallel to each other. So now if you take a look at this quadrilateral out here, what do you get? That you get a triangle and a parallelogram, correct, which share the common base HF and common parallel lines AB and HF. So what can I say? That area of this triangle HEF is half the area of parallelogram ABFH. Let's write this down, then we will continue further. Okay, so I'll say proof, and we will start with our construction. So let's say join points H and F. Now what do we have? ABCD is a parallelogram. This is given. Therefore, AD is parallel to BC and AD is equal to BC. Why? Opposite sides of parallelogram. Correct? Therefore, what do I have? I have AH parallel to BF. Why? Because I have H lying between A and D and F lying between B and C. Correct? Let's mark this as 1, and half of AD is equal to half of BC. Therefore, what do I get? AH is equal to BF. Why? Because H and F are midpoints of AD and BC respectively. I'll mark this as 2. So from 1 and 2, what do you get? Therefore, quadrilateral AHFB is a parallelogram. Why? Because a pair of opposite sides are equal and parallel. So what are my opposite sides that are equal and parallel? AH and BF. So I'll say from 1 and 2. Now since this is a parallelogram, I have AB parallel to HF. And what will I say? Opposite sides of parallelogram AB, AH, FB. Correct? Now, triangle EHF and parallelogram AHFB lie on the same base. So, which is your same base? That is a construction HF here. On the same base HF and common parallels. So, what are my parallels? AB and HF. Correct? Therefore, what do I get? That area of triangle EHF is equal to half area of parallelogram AHFB. Correct? Let's mark this as 3. Similarly, what can you prove? That area of triangle GHF is half the area of parallelogram HFCD. You will prove that HFCD is a parallelogram just like you did here, and then show that HF is parallel to DC and that area of the triangle HFG is half area of your parallelogram HFCD, right? So, I will say similarly we can show that area of triangle. So, we have taken EHF. So, I will say GHF is equal to half area of parallelogram. So, which is my parallelogram? Here I have taken AHFB. AHFB. So, I will say DHFC. Right? Let us mark this as 4. Now, if you add 3 and 4, you will add the left hand side to the left hand side and the right hand side to the right hand side, because when equals are added to equals, the wholes are equal. So, I will say adding 3 and 4, what do I get? Area of triangle EHF plus area of triangle GHF is equal to half area of parallelogram AHFB plus half area of parallelogram DHFC. Right? Now, if you notice, half will come out common over here. See, when you have 2A plus 2B, how do you write it as? You remove 2 common and you say A plus B. Right? In the similar way, I will remove my half common outside. So, I will say area of triangle EHF plus area of triangle GHF is equal to half area of parallelogram AHFB plus area of parallelogram DHFC. Correct? Now, if you take a look at EHF and GHF, so just let's take a look at our triangles EHF and GHF. I have EHF and GHF. When you add these together you get this space, right? So, what is that space? It is EFGH. So, I will say therefore area of EFGH, right, is equal to half. Similarly, if you take a look at your parallelogram AHFB and DHFC, so AHFB and HDCF, what do you get? DHFC. DHFC. What do you get? You get the entire parallelogram ABCD. So let's write this down. Half area of ABCD. Let's take a look. Is this something what we had to prove? Yes. So I will say hence proved. So this was about question number 2 of exercise 9.2. Please take a look. We will continue with the remaining questions in the next videos. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.